When we think of energy change or energy transfer, it's interesting to note that we often can't tell how rapidly or how slowly the energy change or energy transfer is occurring. For example, consider an object that exhibits a displacement delta r in moving from some initial position to some final position, all the while a force F acts on it. In this case, we'll consider, for simplicity, that F is constant. If we know F and delta r, then we can compute the energy transfer, the work done on the object by the force F. However, we don't know whether this transfer took a nanosecond, or a century, or some other time interval. In all cases, the same amount of work would be done. There is a physical quantity that tells us about the amount of energy change or energy transfer in a given time interval. That quantity is called the power, which has the dimensions of energy over time, and corresponding SI units, joules per second, which has a special name, the watt. The concept of power is commonly encountered not only in the physics of motion, but elsewhere in everyday life. For example, we often speak of the power rating of a light bulb. Say, the light bulb is rated at 60 watts. Here, power describes the energy change over some change in time. Specifically for the bulb, this means that electrical energy changes to other forms of energy at a rate of 60 joules every second. In mechanics, the rate of energy transfer by work can be described by the concept of power. So, if we consider another example and add to that the information that the work done by F during the displacement delta r occurred during a time interval of delta t, then the corresponding power is the scalar product of F dot delta r divided by delta t. For small delta t, this is a good approximation to what's called the instantaneous power, F dot dr dt, which is just the scalar product of the force with the object's velocity. Let's close this lecture by trying this example involving the concept of power. You exert a force of 300 newtons directed at an angle of 30 degrees below the horizontal as the box moves across the floor to the right at a speed of 0.75 meters per second. At what rate are you transferring energy to the box? The rate of energy transfer is just the power, which is the scalar product of the force with the velocity, which is the magnitude of the force times the magnitude of the velocity times the cosine of the angle between the two vectors. Working this out, we find the correct answer,